Hey guys, I'm going to talk to you about greatest integer functions. Now these are pretty complicated in my opinion, but once you get the hang of it, it should make perfect sense to you. So, what is a greatest integer function? What this is if f of x, talking about the function, is the greatest integer that is not greater than x. Now right now that probably makes absolutely positively no sense to you, but let's make sense out of it to you. Okay, so what it's asking you is the greatest integer that's not greater than x. So what that's saying is if my number is like 2.35, what is the greatest integer that is not greater than this? So it's either 2 or it's 3. Well, which one is less than that? Because it can't be greater than this, so you have to go down, so it would be 2. So if we had like 3.56, you would have to go down to 3. So it's like the greatest whole number without going, you can't go over. You don't round up, you always go down. Okay, so think about your stair step. So we're going to do the parent function. This one does have a parent function. That's the one we're going to start with first. Okay, so what this looks like when it's asking you for greatest integer is you have an x or whatever your equation is, and it's surrounded by two brackets. So it's like this and then like two sets of these. Don't ask me why, I'm not really sure. Okay, so with that being said, let's make our chart. Okay, so we're going to use a couple different things. We can just start with whole numbers. If our numbers are 1, 0, 1, 2, 3, 4, okay, we just go over 0, 1, 2, 3, 4. Now what is the greatest integer of x? Now what this means is that every number from 0 to 1, not including 1, okay, falls in this category. So it's like 0 is less than or equal to x less than 1. So when we go to graph that at 0, this 0 is included. So anything from 0 to 1 falls in that category. So like if you had 0.5, it would be 0. If you had 0.75, it would be 0. Okay? Alright, so from 1, what that's saying is anything that is greater than or equal to or less than or equal to 1, no, greater than or equal to 1, but less than 2, that's not included. Okay, so this is the opposite of the piecewise step function. So the piecewise step function had open to closed. That is not what you do here. It is closed to open. Okay, so then it looks just like a step function. You go here. So anything from 1 to 2, including 1, would fall into this category. And then you would go here. This one's open. You could even go here. So this is what the parent function looks like for a greatest integer function. Alright, so really it's everything including that number to the next integer. Okay, so let's make a little bit more sense out of that for the next example. Okay, alright, so you're probably going to have something that looks like this. So we're going to make our chart, which is x, then x plus 2. Well, what would that look at like if I wanted the greatest integer of x plus 2? Okay, so don't fret. Here we go. Alright, so let's just put some numbers in. You do not have to do whole numbers here, which is probably going to help you out. Okay, alright, so I'm just going to go 0, a half, 1, 1.5, just to give some variety here, and so you can understand it better. Alright, so what we do is 0 plus 2 gives me 2. Well, what happens there? What's the closest number? Rounding. You don't have to round that one because it's already a whole number. Alright, so you got half plus 2, so we get 2 and a half. So what that asks is, what is the greatest whole number without going over? So we always round down for the greatest integer. So this is also 2. Okay, so if we have 1, 1 plus 2 is 3. Well, we don't have to round because it's already a whole number. All right, 1 1/2 plus 2 is 3 1/2. We don't round up, we round down, so that closest one is 3. 2 plus 2 is 4. We could even throw in like a 2.25 plus 2 is 4.25. So you would round that down to 4 as well. Okay, so what does that look like when we graph it? I'm going to make it to where we don't have any negatives to deal with here. Okay, so what that's saying is anything with 2 here. So really we're taking the parent function and we're going to shift it 2 to the right. Okay, so we're going to start with at 0, 2. So 0, 2. Remember the first one is solid. To the next number, anything in that's going to fall into that category. Okay, so we go to 1, 1, 3. So this is like my y here. So this is your x, this is your y. So 0, 2, anything in here falls in this category. So we go to 1, 3. That works to this number. Okay, 2 and then 4. So go 2, 4, and we continue on. That would be our greatest integer function in this category. Okay, all right, so really you're going to make this one solid, this one open, and then connect the two. This one solid, and then go to the next number, which would be like 2, and go here. Okay, so we could continue this way and look like this. Remember, this is still a function because we got a solid and we got a open, which means there's no overlap if we do our vertical line test. Okay, disregard that comment. All right, so let's do one more. This one's a little bit more difficult. Okay, remember we got to make our chart first. So we got our x, we have what is negative x, and then we want to know what is the greatest integer of negative x. Okay, so we're going to throw in some fractions and stuff here. So let's start with 0. We'll do 1/3, 2/3, 1, 1 1/2, 2. Okay. All right. So what that's saying is what is negative x? Negative 0 is 0. So obviously that is going to be 0. Okay. All right. Remember, this is our x. This is like our y here. All right. So negative x, negative 1/3. Negative 1/3. All right. Remember, we have to round this, but we have to go down, not up. Okay, this can be very tricky when you're throwing into some negative numbers. Okay, so remember, what would be down with this would be negative 1. If we rounded up, this would be 0. Okay, so what do? We go down. Okay, so this is negative 1. Okay, same thing with negative 2/3. Remember, negative 1 and 0, we have to round it down. Okay, then 1, we got negative 1. Okay, that will go to negative 1. So we'll make negative 1 1/2. Remember, that will go to negative 2 or negative 1. We have to go down, which looks bigger, but it's not. Okay, and then negative 2 would go down to negative 2. So what would this look like graphed? Okay, remember this. Our first one is solid going to an open one. Okay, all right, so we have 0, 0. So what that would look like is just a dot here. Okay, so anything from 0 to 1 would be work. Okay, so now we have negative 1. Okay, so negative 1 So let's go to this one. 1, -1. So 1, -1 look like this. So this is going in the opposite direction, and then 2, -2, which makes sense because we have a negative number, so it would be flipped. Okay. All right. So I'm going to attach a few of these to work on your own. These are a bit confusing, but we'll work more of these when you come back. Remember, I'm going to be putting some stuff up for you to work on. Now let's apply it and make a function rule, which is where we started. Okay, so we know what they all look like. Now going from there, I'll also attach a video kind of walking you through that. So, all right, I'll send you some to practice. Remember, all of these go in your journal for your notes. Thanks.